Okay, guys, let's get started. Let's get started with today's lecture. Today, I want to talk more with you about segregation dynamics. We started talking about that on Tuesday, but today we're going to jump into several what we call agent-based models to look at actually how can it be that there is segregation at the macro level while actually there might not necessarily be discrimination at the micro level. I remember that was sort of like the big point. That was like the big point that we had the last time. I think I'm just going to sit down, seriously. I have to sit all day long, teach all sorts of things. So let me at least sit down. Remember the last time we had this. I showed you this common sense theory that we had. Okay, maybe segregation is caused by individuals just not liking others who are dissimilar to themselves. Yeah, maybe people are just racist. Maybe that's sort of like the thing that is driving it. And in some ways, your intuition tells you observe segregation at the macro level. Your intuition tells you that there must be something similar happening at the micro level. That's sort of what your intuition often tells you. Yeah? But it's important to notice that these macro phenomena that we have do not necessarily have a corresponding micro-level behavior. That's crucial, yeah? Because if you would just look at the macro-level statistics and see, okay, there's segregation, you would say, okay, everybody in New York is a racist because they still seem to segregate, right? So how can that be? And that's sort of why it's really important to keep these levels apart from each other, because, and that's sort of what I'm going to show you today, you can reach macro-level segregation even when your individuals are actually very tolerant. Even actually if they would be fine in living in completely integrated neighborhoods, or actually even in neighborhoods where most people are different from themselves, we can end up in very segregated scenarios. How does that work? Well, it is because of this segregation process, because it's not just segregation that is there, but it's sort of like a way how we get to it. Yeah? When we put this in this general picture, you know, we had segregation as the macro level outcome, and the segregation process is sort of like this way of getting there. Why is that the case? Or why can that be the case? Well, what happens when, last time I also mentioned that ultimately still individuals do something, yeah? I don't know, I think it's very important to keep in mind that, especially as sociologists, our units of analysis are often individuals. So there are individuals there, so individuals do something. Yeah? So individuals might move, they move to another neighborhood, or individuals or parents, they take their kids from one school to another school. Yeah? By the way, actually just yesterday I read this interesting statistic that I think in Ireland, there's a lot of school segregation happening actually as well. I think it's in only 23% of the schools in Ireland have 80% of the foreign kids. Yeah? So you see that the foreign kids, they tend to congregate in certain schools, while the Irish people are in other schools in a way. So just a little side note here. Yeah? But what happens when individuals decide, let's say, to move a neighborhood, or when they decide to move a school, or when they decide to move a workplace? Well, two things are affected by it. Yeah? And that's sort of where we ended the last time. First thing is the composition of the neighborhood or the school or the workplace that they leave changes, right? If I, as a foreigner, leave a certain neighborhood, there's one foreigner less in that neighborhood. So the composition of how many foreigners live in that neighborhood compared to how many native people live there changes. It only changes marginally. I don't know, let's say when you look at the big city or the big neighborhood, it only changes a little bit, yeah? But it still changes because I'm not there anymore. At the same time, the neighborhood that I'm moving into changes. Suddenly there's one more foreigner living in that neighborhood because I'm now there, right? So you see how in that neighborhood, let's say the share of foreigners would increase. And so these are the fundamental things that happen when an individual decides to do something, yeah? to move from one neighborhood to another, or I don't know, from one school to the other, and so on. It also affects others. Yeah, and that's sort of like the whole thing about this macro approach. Like individuals do something, but it changes their macro level conditions for others, which then base their individual decisions based on these macro level conditions, and then they do something which then again might change the macro level conditions for others, and so on and so forth. Yeah? And this is sort of where then in the segregation process you can have these chain reactions where like one individual being unhappy and moving elsewhere then suddenly makes other people unhappy that were happy before. Let's say there's somebody else in my neighborhood who likes to live in a diverse neighborhood, and now suddenly I'm moving out. There's one foreigner less in that neighborhood. That neighborhood is less diverse. Well, then this other person might have been happy before while I was there, but now they're not happy anymore, because, and this is sort of where this notion of the threshold comes back. We talked about that in a way. Let's say if their threshold would be now hit, now they would move, and so on and so forth. So that's sort of like, keep in mind that individual decisions, individual choices, they change the conditions for others. And then if individuals kind of do that in sequence, you always have this kind of constant back and forth between individuals doing something, changing the society, and then other individuals doing something, changing the society, other individuals doing something, and so on and so forth. So it goes back and forth. And so individuals, they are part of their social environment, but we also change it all the time. And this is sort of when individual action is embedded in something like that, then you can have these chain reactions. So how do we study these kind of chain reactions, these kind of things? That's essentially where what we call agent-based model come into play. What are agent-based models? Well, I have a whole bunch of examples later on, so maybe you will understand it while I'm using these examples then later on. But an agent-based model is nothing else than a computer simulation. It's not complicated at all. It's a very simple, often it's very, very simple computer simulations where we kind of assume what would happen if individuals would behave in a certain way. Like you have agents, and for us this is often individuals. Biologists use these kind of things sometimes as well. There's ants or some other animals or whatnot. Actually, a friend of mine, he's a climatologist. He uses exactly these kind of models too. But for him, the agents are not individuals, but square meters of air or cubic meters of air, and they kind of simulate what happens to this part of the air. And then there's some physics coming into play. There's wind and blah blah blah. And basically, it's a way of modeling these things where different units or agents influence each other, and then change the environment for others, which then might lead to others behaving in a certain way. So that's what we call an agent-based model. But to come back a little bit, models in general. What are models in general? Models are used essentially in two different ways. Models are ways of in the first way to recreate what we observe in the real world. Yeah? And that's ultimately what a statistical model does. At the same time, a model is a simplification of the real world. Yeah? It's sort of like our best guess how we can actually replicate what we observe in the real world with a set of rules that we actually know. Yeah? So, for example, how do we know that I don't know, when I pick something up and drop it down, that it falls down? Yeah? That this is gravity, and this is sort of how it goes. How do we know that? Yeah? Well, we have a model about that. Yeah? And we can formulate that model in some ways, and that model leads to certain predictions. And then when this sort of our best model is sort of like the best thing that we haven't rejected yet, and the model has the characteristics that we know what we put into that model. So that's sort of sometimes a little confusing, because we don't really know how the world works, but we know how our model works. Because we put it in. We put all the ingredients into our model in it. So when then our model is actually good in replicating the real world, that's sort of often how this thinking goes. Then we draw the conclusions that the things that we put into the model that seem to be good in replicating what the real world looks like, that they seem to be important for the real world as well. But ultimately, what we do is we come up with toy models of what we think how the world works, putting the things in that we can actually change or that we can control in that model, and kind of see how much of that do we actually need to put in to replicate the real world. So, but God, this is sort of like, maybe Owen is talking more about that in his quants class, about what models are and how they go. Models can also be used in a very abstract way. And this is sort of where the agent-based models come into play. These agent-based models, sometimes they are detached from the real world. They're very abstract. And the models that you're going to see today, they're very relatively abstract. There's like a one-dimensional segregation model or a two-dimensional segregation model, and it's extremely, extremely simplified. So here, the point is not to use the model to replicate the real world. Here, the point is to use the model to make a theoretical point about what are the macro-level outcomes of certain rules when individuals behave in a certain way, interact with each other in a certain way. So that's sort of like another way of using models in a more abstract way. And this is sort of where agent-based models come into play. Or a lot of them. Actually, sometimes people use agent-based models as well to try to replicate the real world. There's like calibrated agent-based models. But most of the good agent-based models, in my view, are at this relatively abstract level. Okay, so agent-based models are basically a simulation modeling technique where a system is modeled as a collection of agents. So you have individuals. Just think of this as individuals, and you'll see in a second what I mean with that. And relationships between them, and sets of rules and how individuals behave. And often they are highly stylized and abstract. And you have agents, and you have rules, and you have macro outcomes, and you also have relationships between your individuals. Okay, so in the field of residential segregation, this kind of stuff actually has been very important. The guy that you also read for today, Thomas Schelling, he wrote this influential book, The Micromotives in Macro Behavior. But he also won the Nobel Prize, but actually for something different, for strategic behavior in the Cold War. It's a fascinating guy, an economist, super clever person. So I'm going to talk about his paper. Actually, it's drawn from the journal article, from the Journal of Mathematical Sociology, but he also wrote about it in the book. That's the one that you had to read for today. And I'm going to talk about the one-dimensional and the two-dimensional segregation model. And while doing so, I'm going to keep explaining what an agent-based model is. Okay, so let's talk about this one-dimensional segregation model. So this is now really abstract model for a simple idea, which is this one, that individuals evaluate their neighborhoods. They look at how many people live in my neighborhood who are foreigner like me. Then they base their decisions on that. Let's say if there are less foreigners than a certain threshold, I would move. Or maybe if there are more foreigners than a certain threshold, I would move. Basically, individuals' actions is based on these evaluations of these macro-level contexts. And then in the next step, individual action brings about change in these neighborhoods as well. Like I move out of my neighborhood, there's one German less in that neighborhood. I move in another neighborhood, there's one more bloody German there. And now you see, that we have a feedback. Because by me moving out of my neighborhood, suddenly I change the neighborhoods at two places. At the one that I left and at the one that I joined. And now maybe some individuals that would not have done something before my move, maybe now they are inclined to move because now suddenly their threshold has been reached. At some point they say, whoa, I'm really tolerant, I really like foreigners, but if there are too many of them, I don't know, I'm making a move. So that could happen. And then they make a move, but then they change their neighborhoods again. And yet we have some more feedback. And there we go through. And this is sort of why computer simulations are really nice, because they allow us to simulate exactly these kind of dynamics. What happens? If individuals do something, they change the environment, which then might lead to other individuals do something to change the environment, and so on and so forth. So now what I'm going to do in this one-dimensional case, I'm going to walk you through these 3 different steps. So what is this one-dimensional segregation model of Schelling? Basically, in a very stylized way, he says, okay, let's think of a one-dimensional town from left to right, and he actually used 70 pieces representing 70 different households, and he said, okay, now let's represent them as 2 different individuals belong to, or these households belong to 2 different ethnic groups. I like the hashtag and the zero. Yeah, so that's sort of what he used in his paper. And now at the bottom, this shows you like a random lineup of those 70 neighborhoods next to each other. Yeah, like there's, I don't know, a square, then there's a hashtag, another square and hashtag, whatever. This is like a random assignment at the beginning of this. Yeah. Okay. Now I've been talking about this context, like context matters. So in this case, we need to think about, okay, the neighborhood. What is the neighborhood? And they're different. That's actually where people do research on, okay, let's change the definition of the neighborhood in a way. What Schelling does in this paper, he looks at the neighborhood as the 4 people to the left and the 4 people to the right, yeah, and me included in that. That's the neighborhood. So for the red hashtag here, the neighborhood consists of 5 zeros and 4 hashtags. Yeah, can you see that? If you kind of go 4 to the right and 4 to the left from the red hashtag, and if you would add these all things up, you would have 5 zeros and 4 hashtags. So that could be the ethnic composition that this individual, the red individual, experiences. Now, this would be, I don't know, my neighborhood. I'm living in the neighborhood, and that's sort of the amount of foreigner and the amount of Irish people that live there. While, for example, for this guy, there would be another neighborhood. Yeah, but again, it would be, in this case, this is just pure chance here. It would be 5 zeros and 4 hashtags. Now you see already how this is very abstract. This is like, okay, this is like really abstracting from things. This is like, I'm looking at this one-dimensional thing. There's sort of like zeros and hashtags and whatnot and so on. But these models are being used to then draw conclusions about the dynamics from that. Yeah. And then when we the idea is when we can show that these dynamics matter in these very stylized settings, we can draw conclusions that these kind of processes operate in the real world then as well. So it's less about replicating the real world, but understanding about what are the outcomes, in this case, what are the macro level outcomes when I have certain micro level behavior of individuals. Okay, now we have interdependence here in the model in a certain way. Let's go back to this little figure of the neighborhood. If now 1 zero in my neighborhood leaves, then the composition of my neighborhood is a different one. Yeah? Or if a hashtag of my neighborhood leaves, goes somewhere else, then the composition of my neighborhood is a different one. Because there's 1 hashtag less, yeah? Or there's 1 zero less. Okay. So we have now this interdependence here built in. Yeah? And that's sort of like the fascinating thing, or I find this fascinating, to look at the importance of these interdependencies, yeah? In contrast to other sociologists that don't look at that, which is sort of really puzzling to me. So anyway, so now this segregation model, or the one-dimensional model, like this, the two-dimensional one as well, proceeds in stages, yeah? And it proceeds in rounds, yeah? And these rounds, in this case, now let's work it in the following way, or that's sort of what Schelling uses. He uses a threshold of 50%. So at the beginning of each round, each piece in a neighborhood where more than half of the neighbors have the opposite symbol is marked. So these are the guys that are unhappy. Or this is sort of like in the model how it's being set up. Yeah? So essentially, this corresponds to this idea that individuals want to avoid a minority situation. They are fine with people who are different from them, but they don't want to be in a certain minority. Then they are unhappy. Yeah. And this corresponds to different kinds of assumptions about the real world. That individuals might prefer completely segregated over completely integrated neighborhoods, or that individuals might prefer an integrated neighborhood over any other composition, and so on and so forth. But I want to move on, I want to press on, so I don't want to lose too much time about this. So I want to get you a feeling for these dynamics that actually happen once we kind of have this set of rules that individuals let's move as soon as your threshold is reached, and then you go to the next space that actually fits, that actually where you are happy. Because then, as you'll see, then that move changes then compositions for others, and then they move, and so on, and then we have these chain reactions. So individuals, they evaluate their neighborhoods, okay, and now let's move on. Individuals move. So individuals evaluate their neighborhoods, and we have this threshold. Let's say as soon as there are more than 50% individuals who are different, then the individual moves. So let's evaluate this individual. Yeah, so we mark this individual as unhappy to begin with. Yeah, because there are more circles and hashtags in this individual's neighborhood. Okay, now let's look at that from the perspective of that individual, and that's sort of why it's called an agent-based model, because it's an agent that does something. Yeah, it's a perspective of the agents. Now this individual steps out and moves, and it tries to find the position that is closest where this preference would be satisfied to be in a neighborhood with at least half of the individuals being hashtags. Yeah? And if you would look at that, it actually would be this spot here. This would be the closest spot where this guy then goes. And now, when you look at the neighborhood, now there are more than 50% hashtags in the neighborhood of that individual. Yeah? That would be like one step here, one individual move of an agent. Okay, so this is now a very simple rule, and in a second I'm going to move that on to the two-dimensional case, and there it's probably even more intuitive than in the one-dimensional case. But what happens is that now this individual changed the neighborhood, yeah, and it changed the neighborhood of that the individual left behind, but also the neighborhood that the individual joined. Yeah? So here you see those guys are all affected by this individual leaving. Those guys are all affected by this individual joining now this new position. Yeah? And then this guy is actually affected by it as well, but it doesn't really matter because the composition is exactly the same. Okay, so now what would happen if we kind of then do, and this is exactly how this goes. This goes in rounds. Like the first round, who's unhappy, let's move them. Okay. And now we moved everybody who was unhappy. Now let's reevaluate. Let's look at who's unhappy now. Yeah? And then we mark them again, and then we move them according to the same rule. Again, let's find the next spot where you're, the next location where you could possibly be and where you're happy. Then again, that kind of changes the environment of yet other people and so on. Yeah? And then we go through these rounds, and what happens at the end of the day, if you play this through, and this is now out of the book from Schelling, this is sort of like a starting configuration in a way, and very quickly you end up in a situation like this, that is very, very segregated at the bottom. Like you have a whole sequence of hashtags and a whole sequence of zeros, and again, whole sequences of hashtags and so on. So this is like how segregation comes about from individual moves. But maybe this becomes even clearer when we move on to the two-dimensional segregation model. It's the same idea, but instead of looking at individuals in one go, now we're actually coming a little closer to reality. Now we look at individuals like living on a grid. Like there are two dimensions. It's like on a checkerboard. And actually Schelling, the guy who won the Nobel Prize, he actually did this on a checkerboard, like back in the 1960s. So now each of these positions represents a neighborhood where they could live, right? And then the people around them, I don't know, have a certain ethnic composition and so on. And then they move around on this checkerboard. And this would be now, let's say, and I'm going to show you an example and a nice little website that uses this kind of stuff. So you have like the blue guys, the blue squares and the yellow triangles, and they are happy or they are unhappy. Now I kind of picked out this one guy. So what would be the neighborhood of this guy? Well, there are different kinds of definitions for it, but the most sensible one or the most straightforward one is just everybody who just is one step away from this guy. Yeah? Technically speaking, this is what we call the Moore neighborhood, but it's just everybody in their neighborhood. It's the Moore neighborhood. What would be the neighborhood of this guy? Well, again, everybody who's just one step away, and then we can calculate the ethnic composition for each one of these neighborhoods for this particular individual. Okay, and now we have like a definition of the neighborhood individuals, and that's sort of how these interdependencies are built in. And then we have our individual decisions rules. Yeah. In the one-dimensional case, it was this thing: move as soon as you are in the minority, as soon as there are more than 50% 50% zeros, or 50% hashtags, 50% of the other group. In this case, now I have a little less restricted rule. So actually now I'm just saying, okay, let's move as soon as there are less than 1/3 of my neighbors are like me. Yeah? So basically, I would be happy to be in neighborhoods with almost 2/3 of people who are different from me. So actually, I'm pretty tolerant. Yeah? And that's exactly the point, that with that high level of tolerance, where I would be, all I want is at least 33% of the people around me being similar to me. But that simple rule, with that neighborhood definition and so on, leads to very high levels of segregation, where almost 70% or almost 80% of the people around me are similar to me, even though I only want to have 33% of people similar to me. Yeah. And this is not like three different scenarios, where you see like, let's say the guy in the middle is unhappy. Why? Because in the immediate neighborhood, there are 6 individuals in the neighborhood, 1 is similar and 5 are different. Yeah? So 5 out of 6, that's less than 1 out of 3. Yeah? Or actually 1 out of 6 is less than 1 out of 3. Yeah? So this guy feels like, oh, I'm a little overwhelmed here. There are too many blue people. While this guy is actually happy with that, because he has like 4 blue neighbors and two yellow neighbors. So the blues are in the majority here, but it's at least 1/3 of the neighbors are similar to the guy in the middle. So with this definition, or with this little rule, this guy would be happy, and this guy would be happy too. Yeah. Okay, so now I'm going to show you what happens when this is sort of like the thing that drives behavior. Okay, so I see this now. You see those guys, this guy is unhappy now. Yeah? So he looks unhappy because he's surrounded by mostly blue. Yeah? While those guys over there, they're sort of with that little rule that they want to have at least 1/3 of the neighbors being similar to themselves, all of those guys are happy. So if I drag this guy over here, now he becomes happy. Yeah? Okay, so that's sort of like the very simple rule. Why is he now happy? Because now he lives in this neighborhood. If I look at the neighborhood, now there are kind of 2 yellow ones, there are 3 blue ones. So in this neighborhood, now there are more than 1/3 of the neighbors are similar to this guy now. Yeah? Now there are 2 out of 5 are similar. That's more than 1/3. So that's now the very simple rule. There again, you see like how individuals are. I don't know. This is just what I showed you before. Yeah? Okay, so now we see this now on a bigger board. Yeah, this is now like a random assignment to begin with. Yeah, and now you see some individuals, they are happy and others are unhappy. This guy, for example, is unhappy. Yeah, why? Because I don't know, if you look at this neighborhood, there are only 2 blues, but there are sort of 6, 1, 2, 3, 4, 5, 6 yellow ones. So he wants to have at least 1/3. Yeah? So what this guy might do, he might move anywhere. Let's just move him anywhere. Or let's move him somewhere where he's happy. Let's find a spot here he is happy. Yeah? Okay, and now I could do this with this other guy. Let's say find for this guy a spot where he's happy. Is he happy here? No, he's not happy there. Is he happy here? Well, actually he is happy. Yeah? And then we could move this guy over there, not happy, but here he is. So it's a simple rule of becoming, I don't know, having at least 1/3 of the neighbors similar. But now actually you just saw something. I moved this guy from over there. Now you saw this guy became unhappy. Because now there are more yellow people around this guy. So this guy was happy before, but now he's unhappy because somebody else moved. Yeah? Similar way, if I move somebody away, then somebody else might become unhappy because of that other person moving away. Because the ethnic composition then changed in that neighborhood. So that's basically the thing. So, there's another example. If I would move this guy over here, he becomes happy, and if I would this guy move over here, he becomes happy. Okay. Now we can actually play this out, and this is what an HMS model is. It's like a computer simulation. Okay, now let's pick a guy who is unhappy and move him somewhere where he's happy. This is what's going to happen if I press this start button now. There you see time. This is sort of like the number of moves that are going to happen. And segregation is now a measure for how segregated the world is. So at the beginning, it's relatively unsegregated. Yeah, it's just a random assignment. I could have a new board. It's just a completely random assignment how we start. Yeah. Okay, what's going to happen now? With this very simple rule that individuals just want to have at least a third of their neighbors similar to themselves. So they would be happy with more than 50% of the people around them being dissimilar to them. Yeah? So they are tolerant. But what happens when I do that? Yeah? Actually, you saw how this segregated. Yeah, like one individual moved and then changed the world for somebody else, and then somebody else was forced. Now everybody is happy, but now actually we have quite a lot of segregation there. Yeah? So now, if I would calculate that, actually most of the people are now surrounded by similar people, even though they would be happy with more than 50% dissimilar people around them. So it's because of these chain reactions. And here's sort of like a little example of how you see how this actually can happen. Yeah? So in this case, everybody seems to be happy except this one guy. Okay, let's make this guy happy. So this guy makes a move. It might be me changing my neighborhood. Suddenly now I'm moving into another neighborhood. He can only move where there is a free spot. That's sort of another important thing. Yeah? So, okay, let's move this guy over there. What happens? Well, actually, this guy became unhappy now. Why? Because now in this guy's neighborhood, well, he was really fine with the yellows around it, but now there's actually too many of them. Yeah? Or he wanted to have at least a third similar people around them, but now it's not the case anymore. Okay, let's move this guy over there. So what happens now? Well, actually, this guy is unhappy, this guy is unhappy, this guy is unhappy, and this guy is unhappy. So now actually we started off with one guy being unhappy, but now the guys seem to have really messed it up because now lots of other people are unhappy. Okay, if we move them, let's move this guy over here. This guy, if we move him over here, is still unhappy, so we move him over here. This guy, we can only move him over here. Now this guy is still unhappy, and this guy is still unhappy. Okay, we could move this guy over there, this guy over there, and you actually see what happens. It's crazy, huh? It's just one guy who was unhappy, and suddenly we kick off these cascades, and ultimately, actually what's going to happen is that the only state where everybody is happy is then this little thingy where they are completely segregated. Or actually there's a border in the middle of it. They were fine. They would have been fine with 60% people similar, different people around them. So pretty tolerant, but we still end up in a completely segregated world. So that's sort of like a very interesting thing. And then also this whole thing of tipping points comes into play, because now you can, and this is sort of how these agent-based models work, now you can actually change the degree of this threshold. You know, like here now I have a threshold, let's say, okay, I want to have at least 33% similar to me. What happens if I change that? What happens if I make my individuals, you know, I could run this. This is sort of just what you saw before. It's just a replication of this. Now what happens if instead, let's have a new board, instead my individuals are a little more tolerant. Yeah? So let's say they are fine with at least 25% similar people around them. So we get less segregation. Yeah? And actually, if you would play that out, actually there's a tipping point around 33% where it really jumps off, where there's much, much more. You could also make them more intolerant. Let's say they want to have at least 50% similar people around them. So we get more segregation happening. Okay, now it's a little question. What's going to happen if I make them really intolerant? Let's say they want to have at least 85% similar people around them. What do you think is going to happen? Shout it out. Who thinks there's going to be more segregation than there was before? Yeah? Because they are obviously more intolerant, right? So they are more racist. Yeah? So you would think, okay, there should be more segregation at the end of the day. Let's check this out. There's no segregation happening. So now actually I made my individuals more intolerant. No, actually I made them racist. And there's no segregation happening. Why is that? Because nobody actually finds a space where they're actually happy. There's kind of constantly somebody who's moving that changes the whole thing. So there's no time, there's no opportunity for these segregated clusters to emerge, because there still is one person who's still unhappy and then moves away, and then everybody else is, oh, okay, now I'm unhappy too. Yeah. But that's kind of like a fascinating thing here, you know, like when we kind of what could happen if we increase to very large, high levels of intolerance, we actually reduce segregation, which is completely counterintuitive. Right? So it's completely against our intuition. Okay, let's do something else. This is now another funny example. So this is, let's say, we achieved at that level. We have a certain amount of segregation here, and our individuals are, I don't know, sort of tolerant. They just want to have 33% similar people around them. What do you think is going to happen if I move this now down to, let's say, 5%? Now suddenly I put a lot of effort into, okay, now let's make everybody really tolerant. What do you think is going to happen? Nothing? Somebody else? Why do you say nothing?
No one's going to have much to do.
Exactly. Yeah. So now I put a lot of money in it and made people much more tolerant. Yeah? Let's live together and so on. But we're still living in a segregated world. Why? Because people, they've already found a happy spot where they are, right? So that's another one of those funny conclusions that we draw from this, that kind of, when you kind of change the thresholds then and make people more tolerant, you do not necessarily observe people becoming, or segregation then going away. Okay, and then you can actually play around with that, and I don't know, now you can have all sorts of questions. Okay, what is sort of like the neighborhood definition here, or what happens if I put individuals in a certain way? So this is now a scenario where I make people slightly, as you see now I have them a lower and an upper threshold. So they move, so actually they would prefer integrated neighborhoods in the middle, and they move as either when there are less than 10% similar people around them, or when there are more than 80% similar people around them. Yeah. What do you think is going to happen now? I give people a little bit of a tolerance here, that they also move when, let's say, if everybody is around me is the same, it's too much, I'm also moving. Yeah. Actually, this has a big impact. Yeah? So just making people slightly, instead of changing their tolerance level about when they move about others, we change them now when they moved about similar people around them, and we reduce the segregation here. So, but anyway, so this is sort of a lot of this is agent-based modeling. Yeah, it's a bit of toy modeling where you then can change stuff, but the idea is that can we actually track down these interdependencies? And when we have individual decisions rules, and what is sort of like the macro level outcome of that? So I asked you that question, so feel free to play around with that. Maybe one other thing that I'm going to show you before we're done. Because how do you actually study these kind of things? How do I study these kind of things? Actually, there are computer programs to do these kind of things, and they are incredibly simple, so you can easily learn them. This one is called NetLogo. This is now the same setup. Now the world is a little bigger. I have reds and blues, right? And I have a threshold for when people become unhappy. Let's put it, I don't know, 75%, for example. I set it up. There's sort of some empty spots and so on. Now I can find one guy who's unhappy. This guy, let's move this guy. He moved over there. Find somebody else who is unhappy. Let's move this guy over there to another random spot. Yeah? And then I can run this. And that's actually where the simulation then comes into play. And again, you see that's like the same phenomena that we had earlier. That even though now, in our case, our individuals, they would be fine with at least with 35% similar individuals around them, but we end up in a world where 75% of the people are similar around them. So even though people are tolerant, we end up in a segregated world. What is the big conclusion here? If you see this, if you see that people are living among similar people, it would be wrong, because now I just showed you, and that's sort of where the model comes into play. I just showed you that this does not necessarily mean that individuals are completely racist or intolerant. So the big message is that you cannot, or you should not. You cannot, or you. That you really need to be careful about macro behavior and micro motives, that you cannot conclude from macro level phenomena that you observe to the micro level behavior. Yeah. Okay, so the next reading for Tuesday, we jump into something that I originally wanted to do before the break, but now we do it after the break. It's about the spread of disorder. Yeah. How crime spreads. Okay.